All right, today we're diving into something really interesting, the G2 election system. It's a unique design that tries to tackle some of the absolute biggest headaches in making sure our votes are counted fairly.
So right off the bat, we've got this central puzzle. Think about it. How can you possibly build a system where every single vote is totally secure, completely transparent so we can check the results, but also keeps every single voter's choice anonymous? It feels like you can't have all three at once.
And you'd be right. This is a classic problem. They call it the election security trilemma. Usually, if you try to boost one of these things, like transparency, you end up hurting another, like anonymity. I mean, if you make a vote totally traceable so you can verify it, you risk revealing who actually cast it. So how on earth does G2 try to solve this thing?
Well, G2's big idea starts right here with this thing, a totally self-contained, secure voting container. Instead of trying to lock down a bunch of different polling places and schools and community centers, the whole idea is to create one uniform, repeatable, secure box.
And the real genius of the container is that it forces everyone to follow the exact same standardized process. From the second you walk in to the second you leave, you're following the same steps in the same environment. That gets rid of a ton of variables and just makes the whole thing much easier to secure and audit.
So let's walk through it. First, you get in using biometrics. A machine scans and verifies who you are, then prints out a unique ballot just for you. Then, you walk through a single monitored door, just one way in, one way out. And from there, you head over to the privacy desk to actually cast your vote.
Okay, so you're inside this secure little bubble. But this is where the G2 system gets really clever. How do you actually break the connection between you and your ballot without using a bunch of complicated software that could, get hacked? Well, the answer isn't digital at all. It's mechanical.
Yep, you heard that right. The system uses what's called a mechanical shuffle. It relies on a super simple physical process to literally mix the paper ballots together. That way, even if someone knew the exact time you voted, there's no way they could know which ballot was yours. And this is where it all goes down, at the voter privacy desk. You can see from the picture, it's not some crazy high-tech gadget. It's a physical machine with a very clear purpose: to protect your privacy through a simple, observable process. Let's zoom in on how this thing actually works. This diagram shows you the secret sauce. You've got these individual slots that all feed into collection trays, and those then dump into an even bigger consolidation tray. It's like a physical funnel that creates anonymity. Okay, let's follow a ballot. So first, you drop your ballot into one of a few different slots. Then, every so often, all those slots empty out at the same time into an hourly collection tray. That tray then feeds into a bigger consolidation tray, mixing all the ballots up even more. Finally, all those shuffled ballots fill up a grid, ready to be counted as one big batch. And that right there is the key, because your ballot gets physically scrambled with dozens of others before anyone ever lays eyes on it. That direct line between you and your vote is just gone. It's broken. Your anonymity is protected by a simple, low-tech mechanical process.
So, the vote is anonymous. That's fantastic. But wait a minute. That brings us right back to our trilemma, doesn't it? If it's so private, how do you get transparency? How can you, as the voter, be 100% sure your vote was actually counted and counted correctly?
The G2 system's answer to that question comes down to a single number, 4. It creates a really robust audit trail using 4 different, separate but synchronized video streams. It's kind of like having 4 different camera crews filming the whole thing from different angles. Each of these 4 video feeds has a very specific job. You've got CCTV that records you coming and going. Another camera records the unique serial slip that you get to take home. A third one records the ballot's own digital ID. And the last one records the anonymous ballot itself being cast. But here's the most important part. Look at who stores the footage. It's all different, independent authorities. This is absolutely critical. By separating who holds the data, the system makes it impossible for any one group to connect all the dots on their own. These different offices are firewalled from each other. They're only allowed to share that data if, and only if, an official complaint is filed. That's what triggers a transparent, auditable investigation.
So, what does this all mean for you? Well, you get to take home a physical slip of paper with a serial number on it. Later, you can use an app to look up that number and just confirm that, yep, the system recorded your participation correctly, it saw you come in, and it saw you leave.
If something looks wrong, that serial slip becomes the literal key that allows investigators to unlock and sync up those 4 separate video feeds to figure out what happened. You know, what the G2 system really does is it forces us to rethink the role of physical, mechanical things in our increasingly digital world. It's a powerful reminder that sometimes the most trustworthy and secure solutions aren't the most digitally complex ones. When you put the G2 hybrid model next to a purely electronic system, the difference in philosophy is just stark. On one side, you have digital systems where anonymity depends on layers of encryption, and auditing can feel like staring into a black box. On the other, you have G2, which uses a simple physical shuffle for anonymity in a video-based audit where you, the voter, literally hold the physical key.
And it all leaves us with this pretty fascinating question. In our big rush to make everything digital, have we maybe overlooked the power and the simple honesty of physical, observable solutions? Could it be that the future of building trust in our digital world is, well, a little more mechanical?